All right, you've got highlighters, you've got your calculators. Are you ready to roll? Okay. Okay, welcome to the last stage, probably the most challenging stage of this unit, is you coming up with your own points and then making an equation. Okay, and I've developed a little bit of a system that hopefully helps you navigate these waters, and it's just going to come down to practice. It's just going to come down to practice, I'm not going to lie, okay? So, when you read these questions, and you will have no points given, you'll have no equation, so you know where it's going, okay? You want to somehow, make sure you pay attention to this, you want to somehow determine what is the highest point in the situation, what is the lowest point, and what is the mid. I'm going to tell you this, they're not going to give you all three, but they're going to give you enough so you can figure out all three. All right, guys? You have to see amplitude in it somehow, and you have to see min, max, and mid in there somehow, okay? So, questions will give enough clues to determine all three. So you need to figure out what's the max, what's the min, what's the mid, and what is the amplitude. I think it is fair to say, that if they give you any two, okay, listen carefully, if they give you any two, you can figure out the rest. Okay? For example, if I were to give you the midline is 0, and amplitude is 2. What would the min be? -2, and this would be +2. If the midline is 10, and the amplitude is 5, this would be, if this is 10, and the amplitude is 5, from, right, you go from 10, you go -5, so this would be 5, and this would be 15. You should be able to see 5 in between, okay? So I would erase this. I'm just trying to prepare you mentally for what we're doing next. If I give you the highest and the lowest, let's use easy numbers. If I tell you that this is 50 and this is 10, can you figure out the rest? Do you remember the equation of the midline? Max plus min, that's 60. Divide that by 2. That means that this is 30, right? And can you figure out what the amplitude is just by looking at this? There's a 20 difference here, right? And there's a 20 difference there. See? But do you have a formula for amplitude? Max minus min. So max minus min, that's 40. Divide that by 2, that's 20, right? This is supposed to be 20 now. So you should be able to puzzle it out. You should be able to be like, you know what? Got it. I have this. I know how to get the rest, okay? I think it's fair to say if I give you any two, you can figure out the rest. This is what I call the Yscl. Okay, this is your Yscl. Sorry, kind of. So, but what I mean by that is figure out where is that sine wave going to go up and down, like in terms of your y variables, okay? So this, in my opinion, this is probably step number 1. I'm going to erase all the numbers that I put in there because we're going to do examples where that's going to come up. I just wanted you to kind of prepare yourselves for it, okay? Next. What did I say here? Note, you can start below ground or water. Use negatives. I think that's not a surprise. Okay, let's keep going. Next is going to be figuring out the Xscl. Okay? And so you're determine the period of this function. And that will give us the Xscl. Like how much am I going up by in terms of my X? Okay? Can I, let me show you here. If the period is from a max to another max or from a min to another min, right? One thing that I want you to understand is that we can split this into quarter sections. We can split it into 4, okay? And the reason being is that, maybe follow me here for a little bit. Don't copy this, okay? We're gonna do examples, but imagine this, your action, you're swinging, somebody's holding you up, you're swing up here, and then somebody releases you, right? You're gonna go down here to the lowest, and then back to the highest, right? And if somebody's swinging you, this is gonna continue on forever, right? Well, not forever, but for a long time. Okay, so let's say it takes 2 seconds. Follow me here. Let's say it takes 2 seconds to go from the highest. Pay attention now, okay? Highest to the highest takes 2 seconds. How long is it going to take you to get to the lowest point in this case? If it takes 2 seconds to go from high to high, this will take 1 second to get to the lowest, right? Half of the whole time, because this is a full swing. You go from the top to the low, back to the top. One swing, 2 seconds. So would you agree with me that it would take you a second to get to the middle? Yeah, okay. How long would it take me to get to here? If it takes a second from here to here, that'd be half a second, right? So guess what, guys? It takes half a second to get to the midline, half a second to get to low, half a second to get back to the midline, half a second to get back to the top. So what have I done here? What did I do with this exercise? I've shown you that we will take our period, split it into 4, and then chunk it up into 4 sections like this. If I do this, how many points are you counting right now? 5. 1, 2, 3, 4, 5. If you give signed reg anything less than 5, it will complain. It will say, I cannot do it. It needs 5 consecutive points within 1 cycle. Okay? And that is what we're going to do today. That's what we're going to do today. I'm going to maybe skip this for now because that might confuse you. Sometimes I get too excited when I write these, and I'm sometimes forgetting that you haven't seen this before. So I need to kind of calm down with how much information I tell you up front. So let's go through a few here. Determine the starting point, and then read carefully. This is step number 3. I'll say it one more time. Figure out your Yscl. Figure out your Xscl. How are we going to do that? We go period divided by 4. Can you highlight this? This is basically what I mean by Xscl. We take the period, we divide it by 4. Last step is, where am I starting in this situation? Am I starting, listen carefully, am I starting on the high point? Am I starting on the low point? Or am I starting in the middle? That's what you have to figure out. The question will give you enough hints. Let's do this one for example. A pebble is stuck on the tire at the lowest point. If you have a ruler, I will invite you to do that. I'm going to split this. We've got the 3 here. We're going to split this into quarters. And you're going to do this every time you have a word problem like this. Oh, I messed up a little bit. We're going to add another box here. No, this is not pathways from chapter 4, promise. If you're getting stuck at the lowest point, you would start here. Okay, you start here. What's the only way to go from the lowest point? Up, right? A quarter period goes by, you're in the middle. Another quarter period goes by, you're at the top. Another quarter goes by, you're here. Another quarter goes by, you're there. That's where your 5 points are going to be located, like that. That's what you're going to see. Okay? You go bungee jumping from the top of a cliff, okay? You're starting at the top, correct? Let's quarter this up. What I'm going to do is this, watch this. I go half, and then half of half. Boom, you've got your, you should see 4 this way, and you should see 2 this way, 2 boxes. So we're starting here, then we're going to figure out this, then this, then this, then this. So the action over time, you jump, right? Your height is going to decrease to the lowest point, and then it's going to go back up. 5 points. So you're starting here. Can I just add something to your notes? Please do that. In this case, you start at 0, time 0. Same here, time is equal to 0. If it doesn't tell you otherwise, time is going to be 0. 0, initial is 0. But sometimes they cheat on the exam, right? They don't tell you the story where it starts. They just say, imagine this. Someone is swinging, time goes by, right? You swing, you swing, you swing, and then all of a sudden somebody says, wait a minute, it's been 10 seconds since we started, you're now at the highest point. So it's almost like the story starts 10 seconds into the beginning. And that's not a problem at all. Watch this. A mark on the wheel reaches a maximum point after 10 seconds. We're going to split this box up. We're going to half, and then we're going to half our halves. Okay? What that means is you still start at the top, but what's time going to be equal here at the very beginning? 10 seconds. So it's almost like you're starting from the 10-second mark and you move forward from there, ignoring what happened before. Okay? So you would go from there to there, to there, to there, to there. Question. Let's go back to swinging. If it takes 2 seconds for a full swing, and time it's time 10 seconds here, what is the time going to be here? 12. Because it takes 2 seconds to go from here to here. If you start at time 10, another 2 seconds would mean that here you would be at 12. If another 2 seconds went by, you would be at time 14. And at time 16, 18, 20, right? But we don't care about that. We just want to have 5 consecutive points like this. Okay? All right. Let's go and try one, and then we'll talk. 1 second here. I wonder if we're gonna go to 35 and try this out. Let's read this. The paddle wheel of the SS Beaver was 13 feet in diameter. Highlight that, okay? And revolved 30 times per minute. When moving at top speed, right? Using the speed and starting from a point at the very top, highlight that too, starting from a point at the very top of the wheel, write a model for the height and feet of the end of the paddle relative to the water's surface as a function of time. You're like, whoa, what's happening there? I think the most important part of this whole statement is write a model, right? We're going to write an equation that will model the height over time. Okay? Assume the paddle is 2 feet below the water surface at the lowest point. I'm going to use a different color. At the lowest point. Determine the sinusoidal equation. Guys, when you see sinusoidal, you know it's a sine wave. Don't argue with it. Don't do an exponential. Don't do a linear. Just go with the flow, right? That's a sinusoidal regression. And I will invite you to do this. Sometimes the province gives you something to start off, like a diagram. Sometimes it doesn't. So watch this. Do the Yscl. So let's make ourselves something like this, where you split it into 3. This is the max, the min, and the mid. Then make a box. You go half, and then half the halves. Okay. Make sure you put the phone away now, Sean. That's not where you're going to get the answer to this. What's the lowest point? What do we know in terms of which one of these 3 do we know? Which one of these 3? Which one of these 3 do we know? Do we know this one, this one, this one? The what? Okay, we have a 13 feet. What would the 13 feet represent in this case? Let's look at our wheel. 13 feet is like this, right? The distance across. What could that possibly represent here? The distance from the top to the bottom, right, is 13 feet. Okay, let's keep that in mind. But which one of these 3 do we know? It says here, assume that the paddle is 2 feet below the water surface at the lowest point. They're giving you the min. So what would we put here? We would put -2. Okay? Do we have a way to get to any of the other lines? Can we use the 13 to perhaps go from here to there? Not to here, right? Because this is the distance right across. So we can go like this. We can add 13. What's -2 plus 13? It's 11 positive. Is there a way to get your midline here? Yeah. So 11 plus -2 is 9. Okay. So I go 11 plus -2 divided by 2. That'd be 9 divided by 2. You can't see that, sorry. Which is 4.5 feet. This is my midline. Let's label this midline. Okay, so this is 4.5. Before you go ahead, can you verify that this actually makes sense? Let's try something here. If you go 11 minus 4.5, like if you subtract this, you get 6.5, right? So that means the amplitude here is 6.5. What are you expecting the difference to be here? 6.5 also. So you go 4.5 minus -2. That's also 6.5. So you gotta make sure you understand that it's 6.5 here and 6.5 there. Okay? Is our Yscl done now? Our Yscl is done. Okay, moving on to Xscl. So Yscl is done. What about the Xscl? do that next year. Xscl. What do we need for Xscl? We want to go period divided by 4. That's how we're going to figure out how much we're going up by this way. And what is the period right now? It's tricky. I don't think they will ever do that to you. You're revolving 30 times per minute. But a period is how much time it takes for one revolution. That's what you want. So period is going to be, minute is 60 seconds, right? 60 seconds for 30 revolutions. Sorry, I'm mixing this up. You want to have time per revolution. So, or, did I get that right? 1 second here. I'm doing the math here on the side. Yes. Yes, this is actually right. Sorry. If you go 60 divided by 30 revolutions, okay, what do you get? 60 divided by 30 is 2 seconds per revolution. This is really the period right here, which is very important. Why did I turn it into seconds? Because I find that it's easier to work with seconds rather than go 1 minute divided by 30 revolutions. Listen to me carefully here. I probably overdid it with this question. Like the amount of things that are happening here are a bit too much. Okay, I will be honest. Most likely we will have just given you that it's 2 seconds for one complete revolution. Let's figure out our Xscl. It's 2 seconds divided by 4, which is half a second. This is very important. This is very, very important. Okay, so Xscl, Yscl, done. Now, if you read the question, where are we starting? Are we starting at the top, middle, or min? Top? Jared says top. I agree with him. Okay. Okay, so that means that we're going to start here, and the only way to go forward from there is to go like this. That's what our scenario is going to look like. If you don't get that right, your equation will be partially matching mine, but not all 4, not A, B, C, D. Okay? Okay, so what time are we starting? Are we starting at time 0? They don't tell us otherwise, so yes. So this would be time 0. And what will time be over here? If this is time 0, what does it take for a full revolution? 2 seconds. Okay. So what is my time here then? How much time from 0? I'm going to go up half a second. Okay. So this is going to be 0.5, which means this is going to be 1, which means this is going to be 1.5. And if I add half, I'm back to 2. Xscl, Yscl. Okay? So now, come up with your X and Y. So time and height or depth, whatever you want to call it. At time 0, we're at a depth of 11, like the paddle wheel with respect to the water surface, you're there. Then you're at 0.5, 4.5. Then you're at 1, -2. Then you're at 1.5, 4.5. And lastly, you're After 2 seconds, you're back to 11. And here you have your 5 points. We go L1, L2. We're going to go stat, calc, sin, reg, and come up with our lovely equation. Do we know what A is? Are we expecting a certain value for A? Remember earlier I did the math. What is the amplitude for this thing? 6.5, right? What is the midline? 4.5. So we expect A and D, right, to be 6.5 and 4.5 respectively. Let's enter that into our calculators. Make sure it's set to radian. If it's not set to radian, you've been sleeping during my class, right? (11), 4.5, -2, 4.5, 11. We go stat, calc, sinusoidal regression. It's way down. Do you remember what follows this? Second 1, comma, second 2, comma, math, trace, enter, enter. There we go. 6.5 as predicted for A, 4.5 as predicted for D. And so you just need to figure out the rest. So that's 6.5 sine of 3.1416x plus 1.57 plus 4.5. Will you always have to do this much work? No. I'm pretty sure that if you just make your little grid, most of you are just going to fill in the numbers here and then translate it to a table. Some of you are maybe not even going to bother with this diagram. You're going to go straight to the table. I would caution, because if you go too fast, then you might get it wrong, completely wrong, okay? I'll tell you this, this is usually a 2-mark question. If you get 2 wrong, it's a -1, okay? And if you get more than that wrong, it's a 0. So you want to make sure you get at least 2 right, like for A, B, C, D, right? To get at least 1 out of 2. All right. I'm going to ask you, what is the rest? The other one is graphing, all of that. Right now, I want to just focus on making the equation. That's all I want to focus on. So I'm going to ask you to go to 36. Actually, 36, I might hold off a little bit for now. Can you try 37 and 39? 37 and 39 for now. Page 37 and 39. Let me give you the answer so you can check right away. For 37, you're supposed to get 37, the equation is where's my equation? Oh, here. I'm finding it. I have all the points. For some reason, I don't have the equation. Hold on. I'll give you the answer shortly. 7 are there, okay? Those are the answers you're supposed to get. Do this right now. Okay. I need you to understand this. This step right here probably threw some of you off. The reason I had to do that is you want to know the time for one revolution. That is what the period is. Okay, so period, if you want to write this down, period is the time for one revolution, for one complete cycle. So if they mess with that, if they give you like multiple cycles and a time, you want to go time divided by number of revs. If they ever do that, okay? I shouldn't have done this on the very first question we do together, like that. I shouldn't have done that. So you only need to do that if they give you, look at this, they tell you like you spin 30 times in a minute. You're like, wait a minute, that's not a period. A period is the time for just one, okay? So if that happens, you have to do that extra step. We will do more tomorrow, okay? Please try page 39. Please try page 39 before you come in tomorrow. I will do a very basic AC tomorrow. No curveballs, just basic.